Phew. Hi, this is Matz. Uh, I'm very glad to see you. Uh, and this is RubyConf, and I'm happy to have me in the RubyConf 2020 virtually this year. And due to the Corona outbreak, so everything has changed. So many conferences and events are canceled and or went online, including this one. And I have very less chance to visit the country and less chance to communicate with the members of the Ruby community. The biggest problem is I have less chance to speak in English, so that my ability to speak in English is far worse than usual. So that I'm losing my ability. So please stand. Okay, in this keynote, I'm going to talk about Ruby 3 and beyond. The Ruby 3 will be released December 25th this year, 2020. And since this conference in November, so you have to only wait for a month or so, as planned. The schedule was decided to release Ruby 3 in the year of the Tokyo Olympic. But due to the Corona outbreak, the Olympic game has been postponed. So we discussed about the schedule, and we decided to release as planned, since the Ruby 3 is now really related to the Olympic game. So we are going to release it on the December this year, unless something extremely bad happens. So I wish we don't see any bad things happen. So stay tuned. The releasing Ruby 3 will be compatible and faster and better. So let me talk about the compatibility first. So the Ruby 3.0 should be compatible to Ruby 2.x. Almost Ruby 2.x programs runs on Ruby 3.0 without any modification, hopefully. Because compatibility matters, we have learned a lesson from the past. So almost a decade ago, no, more than that, more than a decade ago, we have released Ruby1.9, which was some compatibility issues. So we have some incompatibility from 1.8 to 1.9. The most changes are due to the encoding support, better encoding support. When we first started working on the Ruby in 1993, the Unicode is less popular than that. So we were working on the more traditional encoding, like ASCII and shift-JIS and the EUC or something like that. But as time goes by, the popularity of Unicode is getting bigger and bigger. So we had to change the language to support Unicode, especially in classes like strings and regular expressions or something like that. But this change had some kind of drawbacks. We had the community split for more than 5 years. Some people stay using Ruby 1.8 for a long time, and the other half of the community went going forward. The similar situation happened in other languages. The Python 2 and Python 3 had some kind of compatibility issues, and they had some kind of the migration issues. They finally declare the end of life of Python 2 this year. So they finally succeeded to migrate to Python 3. And then the PHP 6 has similar situation. And PHP 6 was the drastic improvement to the language, but it was too drastic. So the community refused to follow the new version. So the core team, the PHP core teams abandoned the development of the PHP 6 and restart the PHP 7. The ECMAScript 4 is similar. It was cancelled, and then they restarted ECMAScript 5. So that designing a language is hard. Harder than you may think. And then everyone wants better language. So that your language, you expect your language to be improved. And at the same time, the language designers are mere models, so that we make mistakes. So that if I have a chance to fix the past mistake, that I'd like to, but at the same time, the fixing these mistakes introduces the incompatibility. The language needs of updates. Of course, we have to keep maintaining and improving the language. But sometimes those improvements comes with incompatibility. The programmers love new things. But at the same time, if you are forced to fix your application without your fault, it's kind of pain. That means the compatibility matters to avoid the forceful pain, to avoid forceful pain. But at the same time, we have to keep moving forward because we are open source software, so that we cannot stop moving forward. Otherwise, the open source community will die. We have to attract people. It's contradiction. So that by designing Ruby 3, we design the future of the language. So that as a basic principle, we should keep compatibility, and we try to keep full compatibility, except for a few bug fixes. Unfortunately, some programs can rely on the buggy behavior. So that if we fix those bugs, you have to fix your application as well. In Ruby 3 we have some teeny fixes. I hope you won't hit that corner cases. The basically new features that are implemented to keep compatibility. And then, okay, this is compatibility. Okay, performance. Ruby 3 should be faster to improve the performance, because performance matters. Another lesson we learned from the Ruby1.9 Tragedy is the performance. We had 5 years community split. That's unfortunate, but similar things happens in Python community. The Python3 Problem had they had 15 plus years of split, so that they took more than 15 years to migrate to the newer version Python 3. So we had the 5 years tragedy, then they have the 15 years tragedy. What's the difference? I think the biggest reason behind the difference is our new virtual machine. Ruby1.9 comes with the new totally re-implemented virtual machines called YAV. The YAV runs far faster than 1.8. In some benchmarks, it runs several times faster, and typical some particular benchmarks runs more than 10 times faster. So that was the driving force to migrate to the newer version of Ruby. So that means performance matters. I think the Ruby is fast enough. So for example, everyone loves GitHub. So the GitHub runs on Ruby, and in most of the cases, it's fast enough. Everyone loves Shopify. Shopify is run on Ruby. So no one cares about the implementation language of the site. For example, Shopify, GitHub, or Cookpad, or whatever. So many big web services are implemented in Ruby and running okay. And it may not be ideal, but run fast enough. So the Ruby is fast enough, but on some benchmarks, Ruby is slower. So from this reason, some claims that Ruby is dead. Ruby is far slower than the Go language or Rust language or something like that, while they use GitHub, while they buy things on Shopify. So that they trust micro benchmarks. In micro benchmarks, Ruby is slower or something like that. Okay. That we realized reputation is formed by micro benchmarks. But that's okay. Users make decision depends on the micro benchmarks. So that we also emphasize the result of the micro benchmarks as well. So that's the reason we introduced the JIT compiler, just-in-time compiler. So the JIT compiler dynamically generates the native code, so that improve the performance, especially the titlets. In Ruby 2.6, we introduced the JIT compiler named mjet to try to accomplish Ruby 3.3. So the Ruby 3 will run 3 times faster than the Ruby 2.0 in some benchmarks, especially the Opta, which is the Nintendo emulator. But actually not in Rails application. So the JIT compiler, the current Ruby JIT compiler is not for the Rails application, not for micro benchmarks, unfortunately. But we are improving. So that maybe in some future, later than Ruby 3.0, that we are going to have the faster in real application in Ruby. Even with so the micro benchmarks is important as well. So that we are going to add more and more with the virtual machine optimization. For example, the Ruby 3.0 comes with the object impaction, so that we would have the less memory problem. The garbage collector improvement will help the performance as well in the real application. The other approach to improve the performance is concurrency. The Ruby the the development of Ruby started in 1993. So at that time, we had one CPU per machine. I had the Unix workstation on my desktop in my office back in 1993, which has Motorola CPU, one core, and a few hundred megahertz. So back then, back then, you buy new computer, your software ran faster. So that easy game. So the CPU performance and the clocks is getting better and better each year. But the free lunch is over. So the single core performance saturated for a long time. So it's kind of the limit of the Moore's law. We are in the multi-core age. So that we have the dual core, octa core, the 64 cores in the computer. So that to run faster, you have to use more core. The concurrency is the key for the performance in the modern day. But we have, at least for C Ruby, we have the GL, the global interpreter lock. Because the thread safe runtime is hard. So to implement the thread safety in the current virtual machine, we need the global interpreter lock. So that if we remove the global interpreter lock from the C Ruby virtual machine, your multi-thread program will crash very soon. It's hard to implement the thread-safe virtual machine, especially for existing language. If your language is designed for the multi-core environment from scratch, it should be much easier. But for existing language like Ruby, it's quite hard. So our idea is to improve the concurrency in Ruby language. So we are going to add two new things. One is the Async Fiber, the other is Raptor. The Async Fiber is for the I/O heavy task. It's kind of like an async await in other language. For example, Node.js. So in JavaScript, especially Node.js, every I/O operation comes with callbacks. It's kind of like a callback hell. But they introduce the promises, then wrap the promises in the async and await. So they use async and await to multiplex I/O operations to build a performance. But Node.js itself is the single-threaded application, but it runs quite fast. So the I/O multiplexity is one key to improve the performance by concurrency. The Ruby 2 is not thread aware and not async aware. So it basically uses the blocking I/O for the single-threaded application. But if we use the threads, then we can do some kind of the multiplexity. But the thread is, kind of heavy. In Ruby 3, we are going to introduce the async I/O with fibers. We use fibers instead of keywords like async and await. And then we do context switches on the I/O operations. So you need to specify a scheduler to switch between the fibers. But after specifying the scheduler, so you have the I/O multiplexed the processes between fibers. I mean, async fiber does not use multi-cores, but how can we use multi-core in Ruby for CPU-intensive tasks? The Raptor is our answer. Raptor stands for the Ruby Actor. Yeah, and then raptors are fundamentally isolated object spaces, so that they don't basically they don't share anything. And then communications via sort of channels, but we don't share states. The data can be shared by very limited way. Only immutable data, so that fundamentally immutable data like numbers and symbols and frozen strings can be shared. And deeply frozen object, which is the object that the frozen object that refers to the frozen object recursively, can be shared because we don't know they are fundamentally immutable. So the only immutable data can be shared. So that you don't have to worry about the race conditions, and then you don't have to worry about the state changing or something like that. As an exception, so the classes and modules can be shared between raptors, but you have to handle with care, though, because in Ruby the classes and modules are mutable, so that we don't have no global interpreter lock no longer. So that it's the raptor interpreter lock, so that each raptor has its own interpreter lock, so that if you run the threads in the raptor, so that the threads in the same raptor can be mutually locked, but each raptor runs asynchronously, so that you can use the multi-cores. So those are performance improvement. Okay, Ruby3 should be better. Should be a better language. Whoops, no, not wrong way. So especially for the error bug finding. So we are now in the age of static typing. So the current popular language like Go, Rust, Swift, and others are statically typed language. And then the traditional dynamic type language like PHP, Python, and JavaScript added some kind of type annotations or type hinting. But everyone goes static typing, right? But shall we? I don't think so. But we want more precise checks, especially with the static type checking. But we don't want type declarations. It's boring. It's it's not concise. So we want to detect error earlier by static type checking. So to implement that, we are going to add the Ruby signatures and type prof. The Ruby signature or RBSE short, which is the kind of the counterpart of the TypeScript d.ts. It looks like this. So the class foo has method foo, and the 2s is the strings, or something like that. It kind of looks like the Ruby, and it's specialized for the type description. Ruby 3 comes with the RBS for the core, and the future Ruby gems, the gems will come with these signatures as well, I hope. So the type checker can use these kind of signatures. The IDE can use these signatures. Maybe the editors can implement a better code completion using signature, or maybe your editor will pop up the type signature or type the method information using signatures. The type prof is another software. It profiles the static type of your applications, and then if type prof finds the contradiction in your software, so that you will be reported. And then at the same time, the type prof will generate the Ruby signature for your applications. This is one example. The class foo has two methods, or foo and bar, and then the type prof scans the call graph using the techniques called abstract interpretations. So it checks the integrity of your of the types of your software, then reports the errors or generate the Ruby signature like this. So we want even better Ruby, so that we added few new syntax to the language. The one is the pattern matching, the other is numbered block parameters. The pattern matching is added 2.7, but we slightly improved those pattern matching in Ruby 3.0. Like this. Okay, this is a JSON pattern matching, so that if the JSON data is the person whose name is Alice and who has the son named Bob, so that we report the age of the Bob, age of Bob. And we also added the one-line pattern matching, like this. Okay, it's kind of like assignment in the reverse way. And we can use the multi-assignment. It can be used like a multi-assignment. Or the JavaScript like a decomposition can be done like this. Or maybe write assignment like this. Number parameters are simple. And you don't have to worry about the name of the block parameter but I strongly recommend to use those numbered block parameter in the very simple blocks only. And this is 3.0. But we are going to see the even further future. I have to confess that we have to still improve the implementation of the Ruby 3.0, and we have only one month left, so that we are very diligently working on the new features of Ruby 3.0. But I think the new features are still the bleeding edge, so that we have to improve the stability of the implementation, especially for actors. So that we need to improve for completions of the new features. Some new features may be buggy, especially for actors. And then we need improvement. Okay, that's one feature after Ruby 3.0. And then we welcome the experimentation on the characters and the other features, Ruby 3 features. But I have to confess, it's some of them are still in the experimental stage, unfortunately. Okay. After Ruby 3.0, we are going to work on the supporting tools like Solar Graph, Sorbet, and Rubacop, and better tools enables better user experience, so that we don't have to improve the language if we have the better tooling. So that we need more tools like type checkers, formatters, language server protocol, the performance tuning tools. After Ruby 3.0, what we are going to work on, and we encourage to work on those language supporting tools. So, and we are going to make Ruby 3.1, 3.2, the further Ruby, even faster. The MJet is very restricted yet, so that we are going to work on the multi-layer jet. or lightweight jet on top of the MJet. So the we have the technology named MIL, and or DNSM, or maybe we use the MIL for the lightweight jet. So the interpreter virtual machine and the MIL lightweight jet and the MJet, which is the highly optimized the jet compiler. So that upon the the burden or the more tight loops will run in the more optimized jet. So those kind of the multi-layer jet would improve the performance even further. So, and one more thing. Before telling you some crazy idea, I have some disclaimers. I have shown you crazy ideas in the past Ruby1.9 keynotes. I counted 70% of them actually merged the language. The less 30% of them are less crazy. So I can't tell this idea will come into the language in the future or not. But anyway, I will give you some brand new crazy ideas for the language feature. Which is the static Ruby. Ruby is the dynamic language. We have the dynamic typing, dynamic class via open class, and we have meta programming. So those dynamic aspect of the language is very useful and flexible and powerful. But at the same time, those dynamic nature of the language is pretty hard to optimize. So we are going to add a few sprinkles to the language. The one is the static barrier. Okay. Let's make it clear. This is crazy idea, just idea. Some dynamic aspect will be prohibited beyond this barrier. Class initialization, library loading, which are dynamic. Then when your applications run, so this barrier turn on. So beyond this barrier, some dynamic aspect of the language will be prohibited. For example, the method repetition will be prohibited, so that the method cache will work more efficiently or something like that. So that it can improve the virtual machine performance quite possibly. The other idea is a static interpretation or macros. That means we are going to add some kind of the attribute or the macro things to reform the abstract syntax tree to form the beta language. Unlike other languages, the macro should be macro would have the special notation. We can tell the macro, this is macro, but from the appearance. For example, the language like Julia, you put the at mark before the macros. Or the language, Rust language comes the bang sign after the name of the macros. That kind of explicit notation would improve the clarity of the macro notation, or reduce the confusion from macros. It's just an idea. So I don't know if it comes to the language or not in the future. But anyway, we will keep moving forward to create a better world. And for Ruby community, please join us to improve the world, to create a better language. and a better world with your effort, with your services, with your programming. Thank you.